Hello everyone. Today we are going to understand complement of set. In the last video we had done two operations on sets, that is union and intersection. Today we are going to do complement of set. So let us first understand that what is the sign of complement of set. So we represent it by a dash or a and a small c over that a. Now what does complement of a set mean? The complement of a set means that the set of elements which are in universal set and not the part of set A. Now let us see an example for that. So let U be a universal set which has elements such as 1, 2, 3, 4, 5 and 6, and A be a set which has elements 1, 2 and 3. Now if I ask you that what would be the complement of A, then what would you say? You should say that the complement of A is 3, sorry, 4, 5 and 6. Why so? Because we see that 1, 2 and 3 are part of A. So as I told you that complement of set is a set which is having all the elements of universal set other than the elements of A. So it has all the elements of universal set, that is 4, 5, 6, but the elements which are in A are removed. It is also represented as this. So this particular sign, wherever you see this slanted line, this also means complement of a set. This also means complement. Sometimes you may also see U minus A. This minus also means complement. Basically, when you see U minus A, you have to do the same thing that you do when you have to find complement of the set. Now, let us move to the next topic, that is representation of sets. That is representation of sets. So what do we mean by representation of sets? Representation of sets means that how do we represent the set, the elements in it. So we have basically two methods of representation of sets. The first method is called Rooster form. The first method is called Rooster form and the second method is called set builder form. Once again, what is the first method called? First method is called Rooster form and the second method is called set builder form. Now what is Rooster form? In the Rooster form we write all the elements. We write all the elements explicitly. We write all the elements explicitly. While in set builder form, we don't write all the elements explicitly. We don't write all the elements explicitly, but rather their properties. But rather their properties. But rather their properties. Now let us see with an example. Let E be a set of all the even numbers. So here E would be 2, 4, 6, 8 and so on. Now if I have to write E in set builder form, what would I write? I would write X such that X is equal to 2n, where n belongs to capital N. I hope you understand. What does this mean? Here we mean that when we take n equal to 1, then we would get a number that is 2. When we take n equal to 2, we would get 4. So in this way we represent the entire set in the set builder form. I hope you have understood the two methods of representation of sets, that is Rooster form and set builder form. Here's a question for you. Here's a question for you. Firstly, pause the video and try this problem. Now let's see the solution of this problem. So here we have to find A complement B. Not the complement of A with respect to universal set, but rather here we have to find the complement of B with respect to A. So let's see how do we do this. As you can see that A says X such that X is equal to N and n is the set of all natural numbers where n is greater than equal to 1. So this basically is saying that A is a set 1, 2, 3, 4 till infinity. Now, what's B? B is the set 2, 4, 6, 8 continued, and in this way. So here we can see that A is the set of all natural numbers and B is the set of all even numbers. So if I am asked that what would be the set A complement B, so we would answer all the elements that are in A but not in B. Again, what would be the complement of set A and B? All the elements in A, but we have to remove the elements that are in B. So let's write it. There would be 1, 3, 5, 7, and so on. Now, if someone asks you to write this in a set builder form, then what would you do? Firstly, let's see what are these numbers. So these are odd numbers, or we can say that this is a set of odd numbers. So how does this work? If we have to write set of odd numbers in set builder form, then what do we do? Firstly, we write x such that x is equal to 2n plus 1, where n belongs to w or n. Pause the video and think for a while. Now here n would belong to w. Why w? We will see. Where w is greater than equal to 0. Let's see why here we have taken w rather than n. Because if we take 0, then only we are going to get 2 into 0 plus 1, that is 1. So the first odd number, that is 1, we are going to get only when we take whole numbers. But if we had taken natural numbers, then also in that case we can write a set. Let's see how. Here x such that x is equal to 2n minus 1, where n belongs to n and n is greater than equal to 1. Why here we have taken n and not w? Because we have here used the sign minus. So what would be the first term or the first element of set? Let's name this set C. So what would be the first element of set C? In this case, 2 into n, that is 1 minus 1 equal to 1. So here we get the first element of the set C. I hope you have understood the complement of a set. In the next video, we will continue with functions and Cartesian product. Thank you for watching the video.